Okay, we're going to cover section 2.1. We're going to learn how do you find slope and how does it relate to rates of change. Okay, so you may have defined slope before as rise over run. That's typically what we remember. Okay, rise over run is the same as the change, and change is usually shown by a little triangle in math. The change in the y values over the change in the x values. Okay, so for example, let's just plot something. So let's go right here, -4, -1, and 4, 3. Okay, in the past you may have connected these points. In order to find slope, you'd create your slope triangle and you'd determine the rise, 1, 2, 3, 4, and the run, which is 1, 2, 3, 4, 5, 6, 7, 8. So the rise over the run would be 4 over 8, which is 1/2, and that would be your slope. Okay, it's also the change in the y values. Okay, the y values went from -1 up to +3, which is 4, over the change in the x values, which went from -4 over to +4, which is a change of 8. So the rise over the run, or the slope, is 1/2. Okay, in general, we have a formula. Okay, we want to look at that. So let's just plot some points in general. So let's just say this is x1, y1, and we have another coordinate up here, x2, y2. Okay, let's connect those points, make our slope triangle. Okay, in this case, the rise over the run is equal to what? This is y2 and this is y1. So in order to determine the change here, we would take y2 and subtract y1, and that would be my distance here. Okay. Just like we could have done here, 3 minus -1 is 4. The run is the difference in the x value, so this would be x2 and this is x1, so the distance here is x2 minus x1. Okay, so that's my slope equation. Slope is typically the letter m, like y equals mx plus b. So that would be my formula to find slope without having to go through all the hassle of graphing and creating our triangle. Okay, so we have 4 types of slopes. Four types of slopes, right? We have, let's say I have an xy axis, I could have a line that's increasing, that would be positive. We could have x and y axis with a line that's decreasing and to have a negative slope. Those are pretty obvious, but we could also have a horizontal line like so, which would have a slope of 0. 0 slope. Okay. And finally, we could have a vertical line. Okay, a vertical line has a slope that's undefined. Okay, because there is no run, so it's rise. There's a rise, an infinite rise over no run. So anything divided by 0 is undefined. Okay, so let's do a couple examples here. just say we have negative 4, 3, and 2, negative 6. And we want to find the slope there. There's our general formula. So in this case, let's just say, and it doesn't really matter which one you pick, let's say this is x1, y1, and x2, y2. So we go negative 6 minus 3 over 2 minus negative 4. Okay. So then we're going to get negative 9 over 6, which in that case is negative 3 halves. And is that graph rising, falling, flat, or vertical? And of course it's a negative slope, so it's falling. Okay. Let's look at another one. 7, 1 and 7, negative 1. So in this case, negative, let's make this x1, y1, x2, y2. So negative 1 minus 1, 7 minus 7, negative 2 over 0. Okay. So we can't divide by 0, right? So that would indicate that this is undefined. Okay. Which means that this is a vertical line. You can, if you were to visualize graphing those, you could see that that would be a vertical line. Okay, Seeth. Let's try 3, negative 2 and 5, negative 2. So now we got negative 2 minus negative 2 over 5 minus 3. In this case, we have, this is going to be negative 2 plus 2 then, so it's 0 over 2. Okay, we can take 0 divided by a number, that's just going to give me 0. So slope of 0 would be a horizontal line. Okay, and let's try one more. 5, 6, 1, negative 4. So negative 4 minus 6 over 1 minus 5 would be negative 10 over negative 4. Negative divided by a negative becomes a positive, so we got 5 halves. Okay, that's a positive slope, so it's rising. It's increasing. Okay, so that's how we use our formulas to find slope. Okay. Parallel lines. For parallel lines, the slopes are equal. Okay. Versus perpendicular lines. Okay, the slopes are the negative reciprocal of each other. Okay, what is a negative reciprocal? So if I have say 2/3, the negative reciprocal would be negative 3 halves. Okay. Or if I have negative 5 as a slope, what's the negative reciprocal? Well, we can always write this over 1. It would be positive 1/5. Okay, so these slopes would be perpendicular. Okay, so let's say line 1, here's an example, goes through negative 2, 8, and 2, -4. Line 2 is 5, -5, 1, and -2, 2. Can you determine whether those lines are parallel, perpendicular, or neither? So let's see. So let's find the slopes of the first one. So y2 minus y1, -4 minus 8, over 2 minus -2. Oops. Excuse me. Goofed up. 2 minus -2. Okay, so that'd be -12 over +4, which is -3. Slope of this one, 2 minus 1 over -2 minus -5. Goofing up. So that's going to be 1 over, that's going to become a plus, so 1/3. So -3 and +1/3, are those negative reciprocals? They sure are. So these lines will be perpendicular of each other. Okay, one last thing in this section is how do slopes and rates of change relate? Slope is a rate of change. So let's just look at a definition of rate of change. Rate of change is how much one quantity changes relative to the change of another. Quantity. Okay, so on the graph, as the x value changes, the y value changes. Okay, so that's indicated by the slope. In a real world problem, let's just look at Superior's population. I looked it up. In 2006, we had a population of 26,960 people. 2008, we had a population of 26,223. And in 2010, we had a population of 26,625. Okay. So what if I wanted to determine what's the rate of change of the population from 2006 to 2010? We would find that just like we find slope. So we would take, we're looking for these two right now. We could use these as our y values. So we take the rate of change of the population, so 26,625 minus 26,960 divided by my change in years, 2010 minus 2006, and we would determine our rate of change there. So this would be what, 335? Negative 335. So our population dropped 335 in 4 years. So this would be our rate of change. And we can calculate that. Using a calculator, we determine the actual rate of change per year in that case. 83.75. So Superior is losing 83.75 people per year if we just look at this data. So that's how rate of change and slope relates. So that's it for section 2.2.